Now in this last part I've redrawn the diagram with Arthur sitting at this new point X on the bench, and we're given that the reaction at Q is twice the reaction at R. Let's just write that down first of all, that we're given that RQ equals twice the reaction at R, and we're asked to find out what the length QX is. Now from the first part we resolved upwards, and the equation won't change at all because it'll be the same forces. Okay, Arthur's moved to the right here, say, but the same forces act on the bench. So if we were to resolve upwards, we're still going to have RQ plus RR minus 40G minus the 20G and the 60G, which is 80G, is still going to equal 0. So we get the same equation as we had before. But because we're given this particular result, what we can do now is just simply substitute, let's say, 2RR into here for RQ. So if we do that, let's just say sub into 1, what we're going to have is 2RR there plus another RR, in other words 3R with a little subscript R there, equals 120G. And from this it follows that the reaction at R must equal 120G divided by 3, in other words 40G. 40G newtons. Now if we're to find QX, then all we need to do now is take moments about Q. So I'm going to take moments about Q, so we'll just put that down there, moments about Q. We need a sense, a positive sense, so I'm going to take clockwise as the positive sense. So if we start with, say, the 60G force here, Arthur's weight, then that force is going to want to turn the bench in a clockwise direction about Q. So the moment would be 60G times this distance, QX. So we'll write that in as 60G multiplied by QX. Then we'll have a look at the moment produced by the 20G here, the weight of the bench. So that too is going to want to turn in a clockwise sense about Q. So that's going to be positive 20G times the distance, 0.8. So we've got plus 20G multiplied by 0.8. Now we'll move on to the 40G, and about Q, this is going to want to turn it about Q in an anti-clockwise direction. So it will be minus, and the moment would be 40G times 0.4. So that would be minus 40G times 0.4. We've got one more to go, and that is this reaction force here, which we've already found out from here was 40G. So just mark that in as 40G newtons. So the moment, which way does it want to turn about Q? Well, it wants to turn in an anti-clockwise direction, so that too is going to be in the negative sense. So it would be the force, 40G, multiplied by the distance away from Q, which is clearly 1.6 meters. So we've got 1.6 there. Okay? And because this is in equilibrium, that's going to equal 0. So all that's left to do is just to clean this up and work out what QX is. Well, I notice that there's G in every term, so we can cancel through by G. And what we have here is 60 QX, and this term is going to be 16, and this term will be minus 16, and this term would be 64. So we've got minus 64, and that equals 0. So if we rearrange this, we get that Qx is equal to, well, these two terms cancel out, so we've got 64 over 60. And this reduces down to 16/15 of a meter. Okay, so that gives us Qx and brings us now nicely to the end of this question.